All right, how's everybody doing today? Mr. Muscarella coming at you, and we're going to take a look at problem number 102 from section 2.2. Car is driven 15,000 miles per year and gets X miles per gallon. Assume that the average fuel cost is $1.55 a gallon. Find the annual cost of fuel C as a function of X and use this function to complete the table. All right, so what we're going to do, of course, is go ahead and determine our function. Now, we know that the total cost is going to be the product of the gallons of fuel used times the cost per gallon. Now, we're told that the car is driven 15,000 miles per year, and it gets X miles per gallon, and it costs $1.55 a gallon. So that's going to give us this equation here, where C is going to be 15,000 divided by the number of miles per gallon we get times $1.55. When we clean that up, arithmetic, we're going to end up with 23,250 over X. That's going to be our cost function. So to find the derivative, when you take the derivative of 23,250 divided by X, that's simply going to give you negative 23,250 over X squared. Now that we have that, we would use our handy-dandy graphing calculator to fill in the table appropriately. So go ahead and do that, and let's see if our answers match before we go ahead and answer the next question. All right, so hopefully our tables are matching and we came up with the same information there for that. Now here we're being asked, who would benefit more from a 1 mile per gallon increase in fuel efficiency? The driver who gets 15 miles per gallon or the driver who gets 35. So let's just kind of take a look at these guys. We're going to ignore everybody else. We're going to look at this one and our 35-mile-an-hour guy. What I want you to focus on, actually, R is a value of dc dx, and actually the absolute value of those. And think about that as a steepness for a line, because we're going to take a look at those two values. Now, so the derivative, the absolute value, if you take the absolute value of negative 103 and the absolute value of negative 19, of course, the absolute value of negative 103 is bigger. So looking at the rate of change for those two, the absolute value of the rate of change is larger for 15 miles per gallon than 35 miles per gallon. So the driver who gets the 15 mile per gallon, they would be the one who gets more benefit. So think about it like that. The slope of 103 is a lot steeper than a slope of 19. So that is your solution for the second part of question number 102. All right, thanks for watching this, guys, and hopefully that explains that for you, and I will catch up with you soon. Peace out.